Okay.
Yeah. Okay. For now, let's see. We have 25 more minutes technically. I want to leave some time for questions, so let's go through the basics of Bash. What is Bash? Bash is a command processor that typically runs in a text window where the user types commands that cause actions. Bash can also read and execute commands from a file called a shell script. You might think, why do we use it? Why do I have to learn all this complicated command line stuff? Where usually I would just click, copy, paste, all the things I'm used to. So the first reason is when you just simply don't have a graphical user interface, no mouse, no icons. You would have to run something from the command line. That's how people on Linux typically work. But the second one is more important. If you want to execute a command for 100,000 times, or if you have to open 100,000 files, this is way too much for you and your mouse to click. So it's very useful to learn these commands, and especially when you're using genome data, for instance. So there's a couple commands to be aware of. The cd command is to change directory. So you could do, if you're in a directory which has a subdirectory, say your subdirectory is called homework1. You could just click, you could just type cd homework1 and it will navigate you into that folder. That's just the same thing as clicking a folder in your Finder window on the MacBook otherwise. So that's the equivalent. ls is a way to list the directory's content. And then it's good to know that in general, there are several aspects to a command. So you have a command, its options, and its arguments. And it's crucial that the white spaces are what separates these. So in Bash, white spaces are crucially important. It's very different from R and Python, where they don't matter so much. The only way Bash is able to interpret which is a command, which is an option, which is an argument, is if you use the white spaces correctly. So be aware of that. So here we have a command, ls. We have an option. I'm not actually sure what this option does, but then we have an argument. This one I know what it does. The command is wc. That's I think it stands for word count. Option is L, which means lines. So that means count all the lines. And the argument is the file in which you want to do this, states.txt. I actually think we have all these files also in the GitHub folder. Much like in R, there is a pipe in Bash as well to stream the output from a previous command as the input of a subsequent command. So if you want to count the number of lines in states.txt, and cat, I think it stands for concatenate. It's just a way to print the contents of a text file usually. So if you want to print the contents of a text file and then count the number of lines, this is a way to use the pipe conveniently to do that. What will happen when you use yes pipe head and then option N5? Much like in R, this just lets you show the first 5 lines of the output. And yes is in Bash. If you try it, you might need to do Control-C after, because it will just give you a infinite number of yeses. So the pipe is a little more advanced here. The pipe is actually able to, it will give you the, essentially just 5 Ys, because the yes command will just give you Y endlessly. The pipe here will know to stop that and take the top 5. Correct me if I'm wrong here, Jack. But you don't need to.
Version of,
yeah.
Sorry.
Go ahead.
Which version of Bash should we download?
Oh, good question.
Because I didn't see any documentation specifying.
Yeah, I mean, I'm assuming you're. I mean, I'm working on a Mac. I'm not sure how it works for Windows and stuff, but I'm assuming it's already downloaded, honestly, on that, because this is the language that you oftentimes use in your terminal.
You can change the default shell to Bash on Mac OS, but I'm not sure what that means.
yeah, let's let's go back to this after, okay? Because I'm not so sure how to help you with that right now, but I can help you with that after, and maybe we can put out an announcement if more people run into the same issue. Okay. Yeah, sorry. For now, know that if you want somebody to explain it better than me, you can use man and then the command you want help for to get some help, and it will show you quite a neat explanation. So bash itself is a little programming language. To fully extend its power, you'll need to write a program. So a text file with a header specifying which program to execute the file. To write a program, you will need an editor. Vim is one of the options. You'll have to download it. It should be straightforward to find. I'll go over the very basics, and I can maybe do a little demonstration. To get started with Vim, you will need to do vi and then the file name. Why is this important? Well, you might not have another choice on cluster or cloud virtual machines. Let me try if I can do just a very quick demonstration here. First, I'll show you the basic concepts of Vim. You don't need to be an expert in it. I'm certainly not. Most of the time, you'll write a program locally and then use a file transfer tool. For instance, file to Canon. Vim, the way I use it, let me try and stop sharing my screen and then share it again on a different desktop.
File to Canon means like FTP, or?
I think, yeah, let me get back to you on that. I'm not so sure, but can everyone see this? I just have a little test folder here. Let me see what's in here. I have two little scripts in my folder, hello.sh and math.sh. These are also in the lab folder on GitHub. I can do vi math.sh. This will show you the contents of this file. So I'll get into this a little later in the slide, but we have a first line here. This is this is specifying which program we are using, namely bash. And then this is showing it wants to, we are saying it needs to evaluate certain expressions. 5 plus 2, 5 times 2, 10 divided by 2, 40, what's that called, modulo 21. So now we are in Vim, right? So if I want to insert something into this file, I will need to click I. Now I'm in insert mode. Now I can actually make changes. So how you would usually, if I want to make this 20, that's possible. And then to quit the insert mode, you will just press escape. And then if I'm satisfied with the changes I made, I can do, I think it's colon WQ, and then it will be saved. So now, if we recall what expressions we tried to evaluate, we can see if it turns out right if we do bash math.sh, and it evaluated them. So it ran the program. All right, you can use I to switch to insert mode, escape to go back to command mode, and several tools for navigation. This one is important for saving and exiting, and this is for exiting and not saving. Yeah, I'm linking to a couple of tutorials, even games and cheat sheets that are useful to learn Vim and become an expert at it. So in the interest of time, let's breeze through this a little bit, but we have a couple of scripts already written in the GitHub lab folder. This is how you would write a script in Vim. So say a script called hello.sh. This is what we would write. First, we would start with a shebang, I guess is how you say it. This is used to tell the operating system which interpreter we're using to parse the rest of the file. So here we're saying use bash. That's what you need to take away from this. And then we're saying echo hello world. And then if you then actually run this file, it should just print out hello world. as I just showed in my little tutorial, you can also do math in bash. Really crucial that you actually use the white spaces. As I said, that's the only way bash can interpret the order of things and actually interpret it correctly. So you can't, like in Python or R, you can just type 5 + 2 with no white spaces. These are very important. And then if you want to run this file, you would just run bash math.sh and it will evaluate it. In bash,
is this on the terminal doing the bash commands?
Yes, this is on the terminal.
And if you're like, my terminal is bash, should I turn it like back to shell?
So are you saying maybe bash is not your default shell scripting language? Yeah, well, we need to address that a little later. I apologize if it didn't make that clear, but yeah, I'm not
okay
right now, but okay.
I'll figure it out.
No, we can help you with that, but we'll just do it after the lab. Yeah, for now I'll show you, you can assign data to a variable using the equal sign in bash. You can say variable lab number is equal to 1, and then we can echo $ lab number, and it should say 1, and it does. We can call variable the Empire State New York, so we can also use a string here, and then we can echo the variable, which we then call with the $ the Empire State. All right, so you cannot use a white space after the $ here, that's important. And then using the let command, we can actually modify the value of a variable. So if we want to make lab number 1, we want to make it 2. We would say let lab number is equal to $ lab number. That's how you access this variable plus 1. And this should output 2. So occasionally you might want to run a command like you would on the command line and store the result of that in a variable. So then we would do this by wrapping the command in a $ and parentheses around the command. So here, if you want to, again, in our states.txt file, which just has all the 50 states of the US, you want to run this command, essentially counting all the lines, so it should be 50. We can then save that into a variable called state_n by using a $ and these parentheses. And then it outputs there are 50 lines in state.txt. Something you might want to use sometime.
What does let do?
Let lets you modify the value of variable. So you can assign a variable just like this using the equal sign. Then if you want to modify it later, you can use let.
So you wouldn't be able to modify without using let?
I think you can. I'm pretty sure you can just read. If you call a lab number is equal to 3, it would just be 3. But if you want to do some arithmetic on it, you might not know the previous value of lab number, and then you would have to use let. Does that make sense?
Yeah,
so yeah, you can just rename it, but if you want to do some arithmetic or modify it, you would have to use let.
I see. Thanks.
So note that bash takes in positional input. So if you, let's see, this is the var.sh file that we also have in the folder. It's written like this. So it shows use bash. What this file will do when we run bash on it is it will say yeah, let's just look at it below. This essentially means take all the arguments that we supplied when we ran bash. So when we run bash on this script and we give it these inputs, A, B, 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 and C. These are ways to retrieve the positional inputs that we supplied. So this will give you all of them with the $@ $1 will give you the first argument, A. $2 will give you the second argument, B, B, B. And then $# will give you the number of arguments that were supplied. yeah, you could also ask users to type in a string on the command line by temporarily stopping the execution of your program using the read command. So if we look at let's read.sh, we say type in a string and then press enter, and then you can write down read response. So we store what is entered by the user in a variable called response, which we then echo. So if you run this, it would ask us to type in a string. We would type it in, and then it would just echo it back to us, saying you entered the string we entered. This is a little more advanced. Conditional execution. It's important to know that each command has an exit status. So the exit status informs you if something works as expected. If I enter the name of a command that does not exist into the terminal, then I'll see an error, not 0. So if you just type this into the terminal, this is not something that exists. And then you echo, this is what's called the exit status, the dollar sign. Here it will give you 127. 127 is command not found, essentially. If it runs successfully, it just gives you exit status 0. Because here you are saying echo, I will succeed. Echo is a valid command in bash. So then you can echo the exit status and it will be 0 because it's successful. True and false are also bash commands that give specific exit codes. So if you just type true and then you want to see the exit code, it's 0. If you just type false, the exit code is 1. If you do and or operators, then conditional execution occurs when the execution of one program depends on the exit status of another program. So here you might type true, which gives you exit status 0, and then it will echo program 1 was executed, because in the case of the AND operator, the program on the right-hand side of the AND sign will only be executed if the program on the left-hand side has an exit status of 0. So it's essentially a way of only conditional on whether your exit status is 0 or 1, will it run a certain program. So in this case, the output will not, it will only show program 1 was executed because this exit status is 0. False gives you an exit status of 1, and it will not run this, it will not echo this line. A similar thing applies to the OR operator. Commands on the commands on the right-hand side of the OR operator are only executed if the command on the left-hand side fails. So it's basically the opposite of this. So here only program 2 was executed. Okay, we're doing on time, we're all right. You can also construct conditional expressions, which are logical statements that are either equivalent to true or false. Conditional expressions are always between double brackets. So here we can use the greater than flag. So here you're saying, if this statement is true, we're just supplying this. This will give us true or false. Remember, true or false have some exit status, right? 4 is not greater than 3. 4 is greater than 3. Sorry, it's later. It's like 1 a.m. 4 is greater than 3. So the exit status will be 0. 3 is not greater than 4. So it will evaluate to false, and it will give you exit status 1. Then these binary logical expressions compare 2 values. There are also unary logical expressions that only look at 1 value. For example, you can test whether or not a file exists using the -e logical flag. So let's look at this flag in action. Here we have a conditional expression again. We want to start with this. We want to see, does the file called var.sh exist? If it exists, it should echo true. If it doesn't exist, it should echo false. So yeah, note that there are if and else statements. If statements evaluate conditional expressions. If an expression is true, then the code within an if statement is executed, otherwise just skipped. Elif and else statements also help control the flow of a bash program. And if statements can be nested within other if statements. So this needs an example. We have another shell script written here called guest.sh. It's a longer program, but bear with me. It will prompt you to enter a first number. It will then read your response, store it into var1. Same thing for var2 and var3. And then this is a program that has a bunch of conditional expressions saying if var1 is greater or equal than var2, then it will compare var1 to var3 and then echo var1 is the largest number. Otherwise, var3 must be the largest one. And if we follow the logic here, also note that we close an if statement by fi. This is quite weird. We don't use it in other languages. If we follow the logic here, then we have the final possibility that var2 is the largest number. So much like any other programming language where you can use if and else. There's also a bunch of handy references for this. I know it's a lot we're covering all at once. Don't despair. Note that we